Alright, let's get started with our next series of videos on simultaneous linear equations. So what this is I'm going to write two equations and what we're looking for here is an x value and a y value that when we substitute both into these two equations they will both be true. So we're essentially solving for two equations at the same time and two variables at the same time. So one way to do this is to treat both of these equations as lines. Remember, these are in slope-intercept form, y equals mx plus b, so we can easily graph them. And the solution to both equations will be the point where those two lines intersect, because we're finding an x and y coordinate pair that is a solution to both of those lines. So let's do that. Let's graph y equals 3x plus 4. We have y-intercept of 4 and a slope of 3. And y equals negative 2x minus 1. Y-intercept of negative 1, slope of negative 2. And from this graph, we can clearly see that the point of intersection is right there at point negative 1, 1. And that is the solution to both of these equations. Let's do another one. Let's throw some fractions in here. Okay, this one we will have y-intercept of negative 7 over 2, slope of negative 1/2. So this is saying that where x changes by 1, y changes by negative 1/2. Remember, that's the other definition of slope, is how much does the y change every time x changes by 1. So when x changes by 1, y changes by negative 1/2. So we'll be right there. We go the same direction in the other half, and now we use slope of up 1, left 2. And y equals 2/3 x will start at the origin and go up to right 3. And there we go. The point where these two graphs cross is going to be right here at negative 3, negative 2. Okay, now let's look at one more. Y equals 5/3 x minus 6 and y equals 5/3 x plus 3. So for the first one, we are starting at a y-intercept of negative 6 and going up 5, right 3, up 5, right 3. And now we start at 3 and go up 5, right 3. Now you'll notice here that these two lines do not intersect. So there is no solution here. There is no x and y coordinate pair that will be a solution to both of these equations. And the reason for that is these two lines have the same slope, and if you remember what that means, it means they are parallel lines, and parallel lines do not intersect. Now, oftentimes you're going to get simultaneous equations that are not in slope-intercept form. They're not in y equals mx plus b. So if you're solving this pair by graphing, you could use axes-intercepts, but remember that only gives you a rough estimate of what the graph looks like. We're looking for an exact point of intersection, so we're going to want to convert these equations to slope-intercept form. So we don't get confused here, let's number them. Let's make this equation 1 and make this equation 2. So for equation 1, we'll move the x to the other side and get y equals negative x plus 3. So that is one graph. And for the second one here, we will move the 2x to the other side and get negative 3y equals negative 2x plus 1. Divide both sides by negative 3. Y equals 2/3 x minus 1/3. And that is the second line we will be graphing. So now let's graph the first one. And the second one. We have a y-intercept of negative 1/3, slope of 2/3. Alright, this is a little bit tricky. We have slope of 2/3. So if you look at the graph here, we're starting at negative 1/3. So let's say we want to get up to 1. That means we'll have a change in y of 4/3. So in order for this 4/3 over something to be 2/3, what does the change in x need to be? It needs to be 6/3, because 2/3 is the same thing as 4/6. And 6/3 is the same as 2. So we have a change in y of 2, change in y of 4/3, change in x of 2. So we go up by 4/3, right by 2, and we'll be right there. And without even drawing the rest of the graph, we can see that this is where they will cross, at point 2, 1. Okay, let's try another one in the non-standard form for graphing. And here these are both going to be in different forms, which means we're going to have to do quite a bit of manipulating. So this is the first one, that is the second one, so we don't get confused. So for the first one, let's first move the 3x to the other side. And now divide both sides by negative 2. And we get y equals 3/2x minus 3. That's the first one we'll be graphing. Now for the second one, we'll just divide both sides by 5. We'll get y equals 15/2x divided by 5. So in order to divide this fraction by 5, we can multiply the denominator by 5, which will be the same thing, because the denominator, that's the number you're dividing by. So this will become 15/2 times 5 is 10. 15/10 will reduce to 3/2. And negative 15 divided by 5 is negative 3. So that is the second line we will be graphing. So first we'll graph this one. And now we will graph the second one. But if you notice, they are the exact same lines. They are right on top of each other. So because we ended up with the same lines, they're right on top of each other, which means we have infinite solutions. Because if we pick any point on the first line, it will also be on the second line. If we pick any point on the second line, it will also be on the first line. There are an infinite number of solutions all across these two lines. Alright, now let's go back to a normal one. There will be exactly one solution to this, not no solution or infinite solutions. So at first this looks pretty easy because they're both in slope-intercept form, so very easy to graph. So let's graph the first one, very easy to do that. And let's graph the second one. Slope of -4. For this one, we can just stay in between the grid. It's easy enough to do that. The problem here is that when we draw the graph, this point of intersection is not on the grid, which means we're going to have fractions. Now, it's kind of hard to see it here, and you could figure out exactly if you were very careful, but this exact point right there, you can kind of estimate, but the exact solution is 1/2 -3/2. The problem with this method is that for graphing, if you're not getting a solution that's right on the grid line, meaning you're not getting whole numbers, you're getting fractions instead, graphing is very difficult. And because of this, there are other ways to solve simultaneous equations that do not involve graphing. There are other ways to find this point of intersection. And we are going to take a look at one of those methods in the next video.